So these are still 3 type problems. And then we're going to go ahead and do a 4 type problem. Okay, so writing an inverse function. We're going to start with, let's look at something like this. All right. So if we were to write the inverse function of this, the steps are to replace, if we're writing in function notation, you're going to replace it with y. And then rewrite it. And then keep in mind that with inverse functions are completely opposite of each other. So once you get to this point, to show the completely opposite relationship, you're going to flip-flop x and y. So you get x equals 1/3, y cubed plus 3. Then we're going to solve for y by subtracting 3 from both sides. Because my goal now is to get y by itself in order to write another function. And to get rid of the 1/3, I'm going to multiply both sides by 3. So you get 3x minus 9 equals y cubed. And then to get rid of the cube on the y, you're going to take the cube root of both sides. So you get the cube root of 3x minus 9 equals y. And then to show that that's the inverse function, we usually write the notation f to the negative 1 of x equals the cube root of 3x minus 9. And then keep in mind what we were doing in class on Friday, that you can always double check your work by finding the composition. So if we were to plug this in for x, everything should cancel and you're just left with the variable. So keep that in mind. Okay, for example 3. We're going to start with, let's say f of x equals square root of, 3x plus 5 minus 2. Alright, again, same thing. You're going to replace the f of x with y. Just makes it a little bit easier. Okay, and then you're going to interchange the x and the y. And then our goal is to get y by itself. Well, right now it's stuck underneath the radical. So I'm going to start by adding 2 to both sides. And I'm going to square to get rid of the radical. On the left-hand side, you're going to have to end up FOILing that out because x plus 2 squared means x plus 2 times itself. The right-hand side, I just have that. So let's go ahead and simplify that. You get x squared plus 4x plus 4. When you FOIL, x times x is x squared. Outer 2x, inner 2x, 2x plus 2x gives me 4x. 2 times 2 is 4. Then we have this. I'm going to subtract 5 from both sides. And then I'm going to divide everything by 3. Now when you divide everything by 3, I do want you to keep it separate. So x squared divided by 3 is going to be 1/3 x squared. 4x divided by 3 is 4/3 x minus 1/3. And then your last step would be to put it in function notation. And there you go. That should be your final answer. Again, remember that if you want to double check, you can take that and plug it in for x in the original function, and you should see that they're inverses. With inverse functions, all you have to really keep in mind is that inverse means opposite. So if we were to graph this, it would be the opposite graph of this. If you were to graph that cube root up there, it would be the opposite graph of a cube function. So we're going to see that relationship in the next standard because that's when we start graphing. But for right now, you're just dealing with opposite functions. Okay, go ahead and flip. Example 4, working with inverse functions. So this is a 4-type problem. At the start of a dog sled race in Anchorage, Alaska, the temperature was 5 degrees Celsius. By the end of the race, the temperature was -10 degrees Celsius. Okay, and then they give us the Celsius conversion between Celsius and Fahrenheit. Okay, so what would the inverse of the function be? Well, the inverse of the function, if we thought of c as a y value and f as an x value, let's go ahead and rewrite that. I'm going to go ahead and distribute that through. So 32 times 5/9, the fraction, is 160 over 9. Okay. Inverse of the function, we're going to flip-flop the f and the c. And then solve for c. So if we solve for c, we have to add 160 over 9. And then we're going to multiply everything by the reciprocal of 5/9, which is 9/5. And you get c equals 9/5 f. The 9/5 times 160 over 9, the 9's would cancel, and 160 divided by 5 is 32. Wait a second. Oh, you know what I should have done there. Sorry. Because this is a Celsius conversion, I should have sorry, I should have just left it C and F. So fix that really quick. F. Okay. Now let me just talk through that. In this case, because your Celsius and your Fahrenheit, we have it meaning particular things, like in terms of temperature. When you find the inverse of the function, or the opposite, would be solving for that function, or that f instead. So that's what we ended up doing. We didn't interchange the variables, but actually in this case, because the variables are attached to real life values there, when we flipped them, we really needed f to be what we're solving for, not c. So in this case, the inverse of the function would be solving for f. And in your mind, you're still flipping because you're trying to get f by itself now instead of c. Where all the times where we're doing problems like this, we interchange the variables because we're used to solving for y. But essentially what you did from here to here is you did solve for whatever variable was in that spot. So all we're doing here is we're solving for the variable that's in that spot, not the spot that's already taken. Let's see. Okay. So this is the inverse of the function. This is the Fahrenheit conversion formula. It would be helpful, because that's another question I ask you here, it's a helpful function because it converts to Celsius automatically. For example, if we just had this if we just had this function here, and we had to convert to Fahrenheit, and you had Celsius, you'd have to plug in Celsius, and then you'd have to start moving everything around to get Fahrenheit by itself. We've gotten Fahrenheit by itself, so that if we had a Celsius, you're just plugging it in and finding Fahrenheit. So we're supposed to find the Fahrenheit temperature at the beginning and at the end of the race. So at the beginning of the race, 5 degrees Celsius. Plug that in. 5's cancel, leaving you with 9 plus 32, or 41 degrees. And then at the end of the race, you had negative 10. Those cross-reduce, giving you negative 18 plus 32, which is 14 degrees. Okay. Graph the original function and its inverse and find the temperature that is the same on both temperature scales. Okay, so we're going to go ahead and do this on the calculator really quick. Okay, so I put this function in first. So 5/9 minus 160 ninths. And then I put in this function, 9/5 plus 32. Now, I might have to change my window here a little bit. Maybe up that a little bit. And graph it. Okay, so there's one line. Oh, it looks like we might have to extend it out a little bit. Let's zoom out a little. Okay, so there's one. Okay. So we're supposed to find the Fahrenheit temperature at the beginning and the array. Oh, wait a second. Oh, graph the original function and its inverse. Find the temperature that is the same on both temperature scales. So the same would be this point here where they intersect. So we can actually find that value by going to your calc menu and the intersect feature. With the intersect feature, you don't have to tilt left bound, right bound. You just have to hit enter. It automatically goes to the second curve. Enter. Enter one more time. And it shows the intersection as -40. Okay? So the temperature that's the same on both is 40 degrees Celsius, 40 degrees Fahrenheit, and actually it's -40. So -40 is where they both actually connect there. Okay, so we graphed. We use the intersect feature. Alright. We'll have more examples of this type of problem that you're going to be working on Monday, plus some examples of the F1 practice for 4. That's what we'll be working on Monday. Over and out.